astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists from the European Southern Observatory's Gaia mission spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia 3. The proximity of this space object to Earth makes it the second closest to our planet black hole ever discovered. The nearest one is called Gaia 1. It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of about 9.6 times that of the Sun. It means that it's way smaller than the newly found black hole. Gaia BH3 is located in the Aquila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Okay, we can probably admit that this stellar black hole is just a small fry compared to supermassive black holes, like the one that dominates the center of the Milky Way. I'm talking about Sagittarius AI, Sagittarius A star. This space giant has a mass of 4.2 million Sun. While a stellar black hole forms when a star collapses, supermassive black giants have their own ways of seeing the light of the day. They are usually the result of mergers of progressively larger and larger black holes. But we'll talk about that later. First, let's speak a bit more about how stellar black holes form. When stars near the end of their lives, they typically inflate, lose a lot of mass, and cool to form what we know as white dwarfs. Such massive stellar black holes as Gaia BH3 are believed to form when a star doesn't contain heavy elements and loses not so much mass over its lifetime. Such stars are called metal poor. Afterward, instead of cooling into a white dwarf, this star collapses into a black hole. The companion of Gaia BH3 is a very metal-poor star. It suggests that the star that collapsed and formed BH3 was metal-poor too. Astronomers know of about 50 stellar black holes in the Milky Way. Some black holes are larger than others. You see, the universe is filled with black holes. Some of them are sprinkled randomly throughout galaxies. Others, those giants we know as supermassive black holes, sit at the centers of galaxies. While stellar black holes are usually just a few times bigger than the Sun, such space monsters can weigh from 1 million to 1 billion solar masses. But even though they're so much heavier than our star, they're packed into a relatively small area on a cosmic scale. Of course, the size of our solar system or so. Some astronomers think supermassive black holes could form by several stars colliding and collapsing at once, while other experts state that such space objects might have started growing several billion years ago. At first, a small seed appears somewhere out there in space, which then gradually increases in mass to form a black hole. This seed does it through the process of accretion, which basically means gathering more and more matter around itself. Besides the absence of any precise information about the formation of black holes, there's also the black hole information paradox. If a black hole has some mass, and as we know, these space objects have a lot of it, then according to the first law of thermodynamics, it should have a temperature. And according to the second law of thermodynamics, it should also radiate heat. Stephen Hawking showed that black holes are supposed to emit radiation too. These days, this kind of radiation is called Hawking radiation. It should form at the boundary of a black hole. But after proving it, Hawking pointed out a paradox. If a black hole is capable of evaporating, some of the information it contains can be lost forever. The problem is that the information contained in thermal radiation emitted by a black hole gets degraded. It doesn't repeat any information about the matter swallowed by a black hole before. Such an irreversible loss of information contradicts one of the basic principles of quantum mechanics. Physical systems that change over time cannot create or destroy information. It means we must be missing something. Both physicists and mathematicians have tried to come up with different ideas, but they ended with pretty weird results. Some have even claimed that the universe could be holographic. It means that the universe that we know and love is actually the result of some mysterious interactions at the infinitely distant boundary. I told you, black holes are really strange. At the same time, we have definitely found space objects that seem to have the properties of black holes. For example, look at this image of black hole M87 star. M87. It certainly looks like a physical object, but what if black holes don't exist at all? There's an idea that black holes are actually gravastars, a blend of gravity, vacuum, and stars. This theory was first proposed in 2001 by Emil Mottola and Powell O. Mazur. They hypothesized that at one point during the collapse of a large star, intense gravity might transform its matter into a new state. It's similar to what occurs when atoms are cooled to such low energy states that they start acting like a single superatom. When we speak of gravastars, a star might collapse to the point of the event horizon, or the point of no return, and then its matter is transformed into a new state. It exerts enough outward pressure to prevent the star from collapsing into a physics-defying singularity. In gravastars, an ultra-thin, ultra-cold, and ultra-dark indestructible shell surrounds heavily wrapped space-time. This new form of matter turns out to be very durable, but it's also a bit flexible, like a bubble. So, anything that is trapped by the intense gravity of a gravastar and smashed into it gets obliterated and then assimilated into the shell of this bizarre space structure. One of the benefits of the gravastar theory is getting away with those messy paradoxes connected with information and singularities. But even though this idea sounds kinda cool, it doesn't explain the phenomena we observe, and we have definitely observed something that looks like black holes. On the other hand, look at this shadow. It isn't caused by the trapping of light in the event horizon. It's a slightly different phenomenon known as the gravitational redshift. It makes light lose energy when it moves through a region with a powerful gravitational field. So, potentially, it could be a gravastar. When the light emitted from the regions close to those alternative objects reaches our telescopes, most of its energy is already lost to the gravitational field, which causes the appearance of this shadow. And still, like with black holes, things get complicated when you add rotation to the equation. Many experts are sure that gravastars would not be able to remain stable during rotation. But wait, it gets even more bizarre. There are suggestions that the insides of gravastars could contain a series of thicker shells. Those are known as nest stars, something like a Matryoshka doll. Of course, these theories aren't perfect yet. Astronomers still have to do a lot of work trying to build functioning models. There is also a chance that both black holes and gravastars exist. But then, we've got another problem on our hands. How can we distinguish between the two? Some theories suggest that these different kinds of space objects should also emit very different gravitational radiation. It could allow us to figure out whether we're looking at a gravastar or a traditional black hole. Some people, like the Andaman Islanders, that's a community living in the Gulf of Bengal, see them as burning torches thrown into the air by forest spirits. Others, like some Australian Aborigines, think they're flaming sticks ridden by shamans. If you ask an astronomer though, they'll tell you that a comet is a large object made of dust and ice that orbits the sun. Arguably, one of the most famous space objects of this kind is Halley's Comet. It has left a great impact on our history and understanding of these mysterious falling stars. When this comet passed Earth in August of 1835, for example, it was blamed for the New York City fire that kept going for several nights. At the same time, the Seminole Indians in Florida saw the comet's long tail and believed it marked the day they would lose their independence. This comet came back in 1910, and people yet again saw it as a sign of bad luck. In Chicago, people bent over backward to secure their windows to protect themselves from the comet's dangerous tail. Others bought all sorts of gadgets, like umbrellas or masks protecting from comets. But what's so intriguing about this space body? How come it just pops up around Earth every once in a while? And, most importantly, is it really dangerous? Halley's is what astronomers call a periodic comet. It visits us every 75 years or so. On rare occasions, some lucky people get to see it twice in their lifetime. It last passed Earth in 1986, and it is expected to come back in 2061. Despite this scheduled return, the comet's orbit can't be predicted with precision. That's partly because of the chemical processes happening inside the comet. Halley's orbit may also change due to random interactions with other planets and space objects in our solar system. Its official title is 1Pi Halley, and it's named after English astronomer Edmund Halley. He was the one who studied the reports of a comet nearing Earth in 1531, 1607, and 1682. Based on his calculations, he concluded that these three occurrences had been, in fact, the same comet, returning over and over again. He also predicted its return in 1758. Halley's discovery also pointed out that some comets, like this one, orbited the Sun, but their journey was not circular. If you look at it in 2D, Halley's orbit looks like an elliptical wire dangling from the Sun. Sadly, Halley didn't live to see the comet's correctly predicted return, but it was named after him. According to the European Space Agency, the first sighting of Halley's comet dates back to March 30th, 239 BCE. Asian astronomers noted it down in the Shiqi and Wenxian Tungkao chronicles, but another study claims that we might have first noticed it even earlier than that, during the times of the ancient Greeks. Writings from that period reported a huge meteor that landed in northern Greece, leaving the local population perplexed. It soon became one of the ancient world's most popular tourist attractions. But the authors also noticed a comet in the sky at the time the meteor landed. They also reported the fact that the unusual space object had remained in the sky for about 75 days. Shakespeare himself seems to have written about this comet in his play Julius Caesar around the year 1600. In this work, he included a now famous phrase speaking of comets as unusual signs, saying, "The heavens themselves blaze forth." It wasn't the last time famous writers felt a certain connection with this object. Writer Mark Twain even said in 1909, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." Surprisingly, Twain passed away on April 21st, 1910. One day after Halley's had emerged from behind the far side of the sun. We got a better look at the comet when it last passed us in 1986. Several spacecraft were sent toward Halley's to take samples of the comet's composition. This fleet of spaceships, dubbed the Halley Armada, flew nearby, one of them taking several pictures of the comet's core for the first time in history. We also had much better telescopes to look at the comet as it swung by our planet this time. Based on current studies, there's little to no chance that Halley's Comet could actually pose any danger to our planet. Most of the bad things associated with the comet were just fabrications. Even better, comets in general may have made life on Earth possible. Specialists believe that early in our planet's history, collisions with comets brought a significant amount of water here, which helped to form our oceans. These space objects may have also gifted us organic material necessary for the formation of life. Don't confuse comets with asteroids, though. Unlike asteroids, which are small, rocky space bodies also orbiting the sun, comets are mostly made up of frozen ammonia, methane, or water. They contain only small amounts of rocky material. Because of their composition, comets are sometimes nicknamed dirty snowballs. Comets are made of 4 parts: a nucleus, a coma, a dust tail, and an ion tail. But their nucleus makes up most of their total mass. There are over 3,000 comets that we know of, but astronomers think there may be up to 1 billion of them in our solar system. A comet that is bright enough to be visible from Earth without the help of a telescope is called a great comet. Approximately 1 great comet can be seen every 10 years or so. People have noticed other comets for millennia. However, scientists have concluded that since comets shed a lot of material each time they orbit close to the Sun, their lifespan may be only thousands of years. If you compare that to the age of the solar system, which is 4.6 billion years, it's a relatively small number. Since these space bodies are still present in the solar system today, there must be a source of comets somewhere out there. Otherwise, all comets would have disappeared a long time ago. Another famous comet is named Hale-Bopp. It came very close to Earth in January 1997. The last time it was seen near our planet before, that was during the Bronze Age, back in 2000 BCE. This comet is much larger and more spectacular than Halley's. Its nucleus stretches for up to 24 miles in diameter and can be seen from the surface of our planet with the unaided eye. Comet Borrelly was the second comet to be studied up close by a spacecraft. NASA's Deep Space One approached it in 2001 and gave scientists a detailed report of the comet's black core. This comet is surprisingly lopsided, but the reason for its unusual shape is still up for debate. Halley's Comet appears to have formed in the Oort cloud at the outer edges of the solar system, but Borrelly is said to come from an icy cloud of rocks beyond Neptune, which is called the Kuiper Belt. Comet Hyakutake gave us quite the show when it passed just 9.3 million miles from Earth in March 1996. It looked like an ice blue splash with a faint gas tail. This comet amazed astronomers too, as it produced X-rays 100 times more intense than scientists had predicted. A spaceship called Ulysses passed through Hyakutake's tail in May 1996, reporting that it was at least 350 million miles long. That's double the size of any other known comet's tail. The comet Wild 2 was examined by NASA's Stardust spacecraft back in 2004. The probe managed to fly within 147 miles of the nucleus of Wild 2, giving us some of the best comet pictures to date. It was also the first time we got samples of dust particles from a comet. The precious cargo came back to Earth in January 2006. Its aim was to shed light on the conditions under which Wild 2, and the solar system for that matter, formed those billions of years ago. Wild 2 is about 3 miles in diameter and covered with craters and cliffs. A sound from space? When up there in space, no one can hear you talk, laugh, or scream. Or at least that's how the saying goes. People can't hear anything in space due to its condition. Still, if you have the right conditions, like the hot gas that surrounds the black hole located in the center of Perseus, space can be quite noisy. That's the galaxy cluster 250 million light-years away from us. Researchers caught an actual sound of space, waves rippling through the plasma gas in Perseus. They first realized black hole generates acoustic signals in 2003, but this is the first time they brought these signals to the human ear. And, wow, this sounds terrifying. Canyons filled with liquid on Titan. Almost a decade ago, NASA spacecraft discovered deep canyons on one of Saturn's moons, Titan. They're about a half-mile wide and they kinda look like the Grand Canyon, but they're filled with liquid hydrocarbon. This was the first time we came upon evidence of canyons and channels filled with liquid on Titan. Our solar system is full of small particles and bigger rocks that circle the sun, the same way as planets. Sometimes it happens some of them change trajectory, which is why falling pieces of debris strike the planets. Most of the meteorites and comets originate in our solar system, some from the asteroid belt between Jupiter and Mars, while others come from the Kuiper Belt, that's located beyond the orbit of Neptune. But 5 years ago, scientists found something unusual, a red, elongated floating space rock called Oumuamua. It could be more than 3,000 feet long, but its size still wasn't the most impressive part. It was the first interstellar object we saw passing through our solar system. It means it formed and came outside of it. It was traveling way faster than asteroids and comets from within our solar system. No one knows where this weird object came from. Many years ago, when it started its journey and sailed away from its parent planetary system, the stars weren't in the same position as they are today, so it's hard to pinpoint where Oumuamua ran away from. The rock could have been on its journey for billions of years. Solar termination events. Our sun is not just a flaming ball of gas we see in the sky. It's actually a pretty complex network of towering plasma fountains, magnetic fields, and blobs of unusual matter 500 times bigger than our own planet. And then there are solar termination events. When it comes to its activity, our sun goes through a natural cycle of troughs and peaks. Approximately every 11 years comes the time when the sun is more active than in other periods of the process. As the cycle goes to the end, there are fewer emissions and sunspots. That's because magnetic fields are weakened at that point, and they collide along the sun's equator. This results in enormous tsunamis of plasma. They pass across the solar surface for weeks. These are the most powerful storms in our solar system. They twist, snap, and lash out into space, and seriously affect our power grid. As they wake, large spots start to form on the sun, close to the strong magnetic field lines. Usually, that's when the cycle begins all over again. No one still knows why exactly they form. Also, we're not sure if this only happens at the end of the cycle, and knowing more about this could help us prepare for raging solar storms better. Tsunamis on Mars. It appears the shorelines under the Martian surface formed because of two enormous tsunamis. Mars has something that's probably the longest landslide in our entire solar system. The rocks rolled down the mountain probably billions of years ago. They fell into the water and caused a gigantic wave that rushed across the Martian landscape. As the tsunami was getting bigger, the rocks scraped all along the solid ground beneath them, and these sandy waves left their prints on the shoreline, not so close to Olympus Mons. That means it's possible the waves traveled a couple of 100 miles. This supports the theory Mars once had an ocean hidden below its dry desert surface. Sure, Oumuamua was cool because it was the first object we've seen coming from outside of our solar system. It's past us now, so it's not possible to study it anymore. But something else came from outside of our solar system after Oumuamua. A comet called Borisov. It came with a tail over 100,000 miles long. Teams got the first images of Borisov in 2019. A bright white glow was surrounding it, and that was one of the first signs where scientists realized this comet wasn't from our solar system. They tried to collect as much information as possible because they remembered how quickly Oumuamua got away. Borisov came from a freezing place as cold as the Kuiper Belt. One theory says it may have originated around a red dwarf, which is the most common type of star in our galaxy, the Milky Way. But, unfortunately, Borisov was also very fast. So fast they only managed to see it a couple of weeks before it passed our planet. By now, it's almost out of our solar system. Finding new planets is always such a thrill, just like it was in 2017, when a group of researchers discovered Super-Earth. It's an exoplanet, which means it orbits a star outside of our solar system. This one has a mass almost 3 times that of our planet, and it's only 21 light years away. It orbits M dwarf star, and it manages to make a full circle in only 2 weeks. So that's how long the year is on this planet. It's closer to its star than Mercury is to our sun. But M dwarf stars are cooler than our sun, so it's possible this planet still has water. Super-Earth is generally a term for planets that are lighter than ice giants such as Uranus and Neptune, yet more massive than Earth. They can be made of rock, gas, or even a combination of both. The one they discovered in 2017 is especially interesting because this type of planet can also hold some form of life. Leroy Chiao is an astronaut who commanded the International Space Station back in 2005. This one time, during his final spacewalk, some pretty unusual lights caught his eye. It looked like 5 lights flying near him. They were in the shape of a pyramid since one light was a bit further ahead. Chiao immediately called one of the crew members who was also out there at the same time, taking a spacewalk. He asked his colleague if he saw the flying objects, but apparently he didn't. Researchers were intrigued by this story, so they examined satellite images to see if that was the thing Chiao saw. One of the options was that Chiao had seen fishing boats off the coast of South America. With bright lights, they wanted to attract squid. But since it was twilight time, the rotation of our planet may have made them appear to fly by. Neutron stars slamming into each other after a massive star comes to its end in a strong supernova explosion. Its core falls apart. Then, it forms the densest form of matter we know about in the whole universe, called a neutron star. In only a couple of the first few seconds after a regular star begins transforming into a neutron star, the energy there is equal to the total amount of light all stars in the universe emit, at least the part we can observe, which is still a lot. It's hard to determine their real size, but picture it this way: the length of Manhattan with 1.5 times the mass of the Sun. If a star here were any denser, it would just collapse and form a black hole. Scientists captured 2 of these stars colliding a couple of years ago, 2017, and such impacts are extremely powerful. They create gravitational waves that lead to a ripple in space-time, but they produce heavy elements like platinum and gold. Imagine a powerful giant, like the Sun, clashing with a tiny yet mighty opponent, a small black hole. The collision is imminent, and the fate of the solar system hangs in the balance. Will the Sun be able to withstand the intense gravitational pull of a tiny black hole? Or will it be swallowed whole? The answer lies in the forces at play in this mind-blowing cosmic collision, so let's break them down. First of all, what is a black hole? A black hole is a region of space where the gravity is so strong that nothing, not even light, can escape from it. Like a cosmic vacuum cleaner, it sucks up anything that gets too close. It's so massive that it warps the fabric of space-time around it. Black holes are one of the most scary and mysterious objects in the universe, a powerful force of nature that defies our understanding of physics, a true enigma of the universe. Black holes come in different sizes, from small ones that are only a few miles wide to supermassive ones that are billions of times the mass of the Sun. Most of them are formed by the collapse of massive stars. After the black hole is born, it starts to grow in size by eating everything in its path. And if 2 or more black holes collide with each other, they can merge into one enormous cosmic monster in a terrifying dance. But what about the smaller ones? The smallest known black holes are called stellar black holes. It's a type of a black hole that weighs 3 to the 10 masses of our Sun while being very small. It's like taking all the matter in the solar system and squeezing it into something the size of New York City. And yes, it's considered very small. Just for comparison, intermediate mass black holes weigh between 100 to 1,000 solar masses, and supermassive black holes weigh millions or billions of solar masses while being unimaginably huge in size. So stellar black holes are basically nothing compared to their relatives. Imagine a massive star, bigger than our own Sun and with a heart made of nuclear fuel, burning bright and hot. But as the star runs out of fuel, gravity takes over and starts to squeeze the star. The more it squeezes, the hotter it gets, until the star's core reaches a temperature of billions of degrees. Eventually, the core collapses under its own gravity. This creates a massive blast called a supernova. This collapse creates a singularity, which means a point of infinite density and gravity. This point is surrounded by an event horizon, the invisible line beyond which nothing, including light, can escape. And just like that, voila! A stellar black hole is born. Pretty mind-blowing, isn't it? Stellar black holes are the most common type of black holes we know of. These guys can be found all across our galaxy. So what are the chances that such a little monster will come for our sun? And in that case, what will happen to us? Well, actually, the likelihood of the sun colliding with any black hole is incredibly small. It's almost impossible for it to happen. Even though stellar black holes are the most common type of black holes in our universe, they aren't common at all. The chance of the sun and some black hole crossing paths is so rare, it's basically like winning the intergalactic lottery. Only this win wouldn't be that pleasant. For 2023, the closest known black hole to our solar system is Gaia BH1. It's about 10 times heavier than our sun, and even this one is about 1,600 light years away from us, which is quadrillion miles. So it's safe to say that our sun is not going anywhere anytime soon. But never say never, right? Just like with any astronomical event, we need to understand the different ways something like this could happen. For example, it would be possible if a rogue black hole passed through our solar system, much like a comet or asteroid passing by. Unfortunately, unlike comets and asteroids, black holes are invisible and can only be detected by their gravitational pull. So it's not like we'd see a big, ominous black hole hurtling towards us. Rather, we'd only know it was there if it caused some sort of disturbance in the orbits of nearby objects. So now what? We know that the sun is a massive, luminous star at the center of our solar system. It's about 4.5 billion years old and has enough fuel to last for another 5 billion years. This star is so big that it's hard to even comprehend its size. In fact, if you were to put all the planets in our solar system inside of it, there would still be room for more. And it's so massive that it contains almost 100% of the total mass of the solar system. So it's hard to imagine how some insignificant, small black hole thousands of times smaller than this star can devour it. And you're right, it won't. Well, at least not completely. So, imagine if a rogue black hole arrived in our solar system and has begun to approach the sun. As it gets closer and closer, the black hole's immense gravity will start to pull material from the surface of the sun. The sun would start to get stretched and distorted. This is called spaghettification. Imagine a rubber band being stretched until it snaps. This gathered material will form a swirling disk around the black hole, called an accretion disk. As more and more material is pulled in, the disk will heat up and start emitting intense radiation. And as the sun gets pulled in, it would start to release massive amounts of energy in the form of light and heat. The sun would become much brighter and hotter than before. The sun's outer layers would be vaporized, creating a massive cloud of gas and dust that would expand outwards. It would be like a cosmic fireworks show, but with terrible consequences. Even though it would be one of the most spectacular views in the universe, we wouldn't be able to see it. As you might have guessed, the Earth would be in for a really rough time. The intense radiation and solar material would cause massive wildfires, and the intense heat would vaporize the oceans. The Earth would be bathed in a constant stream of high-energy particles, and the atmosphere would be ionized. In short, the chances of any life surviving would be close to zero. And this collision would have far-reaching consequences, not only for the Earth, but for the entire solar system. The intense radiation and heat would vaporize everything in its path. All of the planets would be destroyed. Now, the sun, being a much larger object than a typical star, wouldn't be completely devoured by the black hole, but it would be significantly distorted and disrupted. The intense gravity of the black hole would cause the sun's outer layers to be pulled away, creating a massive blast, called a tidal disruption event. But either way, in the end, the black hole would win. It would grow in size, and a new accretion disk would form around it. As we've seen, the collision of the sun with a black hole, whether it be a tiny or stellar one, would be an epic and catastrophic event. But thankfully, as we've already mentioned, the likelihood of such a collision happening is extremely low. However, that doesn't mean we should stop studying black holes and their potential impact on the universe. The more we learn about these mysterious objects, the better equipped we'll be to understand and predict their behavior. So let's keep researching, exploring, and observing the depths of space. And who knows, maybe one day we'll come across a black hole that's just too curious and gets too close to the sun. Let's hope that by that time, we will already be living on other distant planets. Imagine a being so powerful, it can suck in entire galaxies, so mysterious, it's invisible to the naked eye, and so impressive, it bends the very fabric of space and time to its will. Yes, meet my mother. Just kidding. Actually, meet the ultimate superhero of the universe, the black hole star. What is it, and how does it work? The universe is full of marvels, and the black hole star is one of the most impressive ones. It's a supermassive force that can bend the laws of physics, and a true enigma for scientists to unravel. No wonder science fiction writers find them so captivating. A black hole star, also known as a Quasi star, is a hypothetical type of extremely massive and luminous star that may have existed early in the history of the universe. They're predicted to be as luminous as a small galaxy, but unlike modern stars, they weren't powered by nuclear fusion in their cores. A quasi-star's energy would come from material falling into a black hole at its core. And yes, just like a normal black hole, these stars have the power to suck in anything and everything that gets too close, including stars, dust, and even entire galaxies. But how is it possible that the star is born from a black hole? And what's more, how do they continue to coexist together? Well, first, let's discuss how black holes are born in general. It all starts with a supermassive star, one that is at least a few times more massive than our own sun. This giant of a star burns bright and hot, shining with the light of 1,000,000 suns. But eventually, it runs out of fuel and its fate is sealed. As its lifespan comes to an end, it makes one final, massive boom. A blast so powerful it can outshine an entire galaxy. This blast is called supernovae. During this boom, the outer layers of the star fly away while the core gets squished together by its own gravity. If the squished core is heavy enough, it can keep squishing until it becomes a black hole. And just like that, a black hole is born. Don't even try to put diapers on this thing. Now, this cosmic monster baby can continue to grow by swallowing up anything that gets too close, including stars, dust, and even entire galaxies. This is basically what's happening now in our universe, with supermassive stars. But what about quasi-stars? The formation of a quasi-star could only happen early in the development of the universe, before hydrogen and helium were contaminated by heavier elements. And because of that, quasi-stars have one important feature. They are gigantic. They may have been dwarfing even the largest known modern stars like VY Canis Majoris and Stephenson 218. No wonder they're so scary. They were born from protostars, one of the first stars in the universe, the great-great-grandfathers of, everything. So now imagine a protostar so massive that its core collapses into a black hole, just like we described before. But the key difference is that in a regular supernovae, the outer layers of the star are blown away by the energy released during the boom. Meanwhile, in a quasi-star, these outer layers are massive enough to absorb the energy without being blown away. What do we get in the end? A star with a black hole in its core that weighs from 1,000 to 10,000 solar masses. This quasi-star is about 14,000 times bigger than our sun, which makes them bigger than any star we know today. Once a black hole is formed at the center of a giant protostar, it starts to give off a ton of energy. This energy helps to balance out the force of gravity, making it kind of like a giant fusion-based star. They would be so bright that each one would look like a small galaxy. Quasi-stars would have a pretty short lifespan, around 7 million years. Just for comparison, Our sun is about 4.5 billion years old, and it's only halfway through its lifetime. But either way, during this short period, the black hole at the center would grow to be about 10,000 times the size of our sun. Quasi-stars are also thought to be super hot, with temperatures reaching over 17,500 degrees Fahrenheit. But as a quasi-star gets older, it starts to cool down, and its outer layers become see-through. Eventually, it cools down to a temperature of 6,740 degrees Fahrenheit, and at that point, it's curtains for the quasi-star. It can't survive at that temperature, so it just dissipates, leaving behind an intermediate mass black hole. Unfortunately, right now, there's no observational evidence for the existence of quasi-stars. This is because they are thought to have only existed a very, very long time ago. They may have been very massive population 3 stars, which are extremely rare and difficult to detect. It's also very unlikely that any of them would still exist today because of their super short lifetime, only 7 million years. So why do scientists believe that quasi-stars could have existed? Because they're looking for ways to explain how supermassive black holes formed so early in the history of the universe. They're found at the center of most galaxies. But how could these monsters have formed so quickly? After all, it takes a really long time for small black holes to grow into supermassive ones. This is where the idea of quasi-stars comes in. These stars aren't just destructive forces of nature, they're like the black belts in the martial art of gravity. They can bend and twist anything to its will. That's why these stars, if they really existed, had to play a crucial role in the evolution of galaxies. They must have been instrumental in shaping the universe as we know it, so those intermediate-sized black holes that they left behind could eventually turn into supermassive black holes in the centers of galaxies. But we're still yet to solve this cosmic mystery. Detection and study of black hole stars is like trying to find a needle in a haystack, only instead of a needle, it's an invisible and mysterious object, and instead of a haystack, it's the vast expanse of space. But with the help of some pretty cool technology and a lot of brainpower, scientists are getting closer to uncovering the secrets of these celestial giants. Here are some things that can help us in this research. First of all, gravitational waves. They're like ripples in the fabric of space-time caused by the movement of massive objects. Albert Einstein predicted them way back in the 20th century, but they were finally detected only in 2015. We caught them by observing the collision of 2 black holes. This discovery confirmed that black holes can merge, and that they're a powerful source of gravitational waves. Scientists think that by studying these waves, they can learn more about how black holes form and grow. Right now, they use a special space probe, LISA, to study them. By combining the information from LISA with other observations, scientists hope to learn more about these terrifying celestial objects. We can also try to detect quasi-stars by observing the effects of their gravity on nearby objects. And, of course, we can use our technologies, such as X-ray, infrared, and radio telescopes. This allows us to study black holes in various ways and at different stages of their lives. In other words, scientists are working hard to uncover the secrets of these celestial giants. We develop new telescopes, search for primordial black holes, and try to understand the connection between black hole stars and dark matter. And we're making some pretty incredible discoveries, just like with gravitational waves. And when we find out the truth about them, it will become a new page in our scientific history. In a galaxy far, far away, we found the most luminous object ever discovered, ACSN Sure 15 Lao AH. Astronomers were left scratching their heads, wondering what kind of beast could produce such a mind-boggling amount of energy. But just when they thought they had this cosmic enigma all figured out, this object vanished into the depths of space, leaving behind nothing but a faint memory and a few bewildered astronomers. Fast forward to today, and it seems the universe has decided to play a cosmic prank on us. That's right, folks, Assassin 15LH is back. And now it's brighter than ever. So, let's take a look at this impossibly bright space object. This event was first detected on June 14, 2015. We noticed it in the southern constellation Indus. It was located within a faint galaxy, which just goes to show that sometimes the brightest things come from the most unexpected places. It's like finding a diamond in a pile of rocks, or a chocolate chip in a batch of oatmeal raisin cookies. No offense to oatmeal raisin lovers out there. ISSN 15LH was so luminous that if it were in our own galaxy, it would shine brighter than the full moon. Imagine that. No night, no stars, just this mysterious thing lighting up the sky like a giant flashlight. Wouldn't that be cool and kinda terrifying? But in all seriousness, it was a fascinating astronomical event. At its peak, it was 570 billion times brighter than our sun. That's so bright, you'd be blinded by the sight of it even from afar. So, picture this. It's 2015, and astronomers discover the brightest object ever observed. It was one crazy discovery, because scientists had no idea what it could be. Is it a supernova? Is that TDE? What in the world is this thing? But then, as soon as they started to study this thing, it started to fade away. That was a huge bummer. Scientists could only sit with their theories and wonder what it could be. But then, against all odds, ISSN 15LH did the astronomical equivalent of a double take, and suddenly got brighter again. Astronomers were like, wait, what? Is that thing coming back from the underworld? For 40 days, its ultraviolet radiation charged up and increased fivefold. Then, it plateaued for a couple of months before finally dropping away again. And then astronomers were like, okay, that's just weird. So what is this thing, and what caused its resurgence? Well, there are a few theories. A supernova is like a star's grand finale. When a star runs out of fuel, it reaches the end of its life. And then, it undergoes a cataclysmic event, releasing a tremendous amount of energy and light. And this beautiful, crazily bright event is called supernova. It's like the ultimate mic drop, except the mic is the entire star. So, some astronomers think that this mysterious object might be a supernova, but a really, really big one. If once it was a star, it probably was 100 times more massive than the sun. We've never seen such supernova before, but maybe this star was gigantic and really loved attention. Next, we have the magnetar theory. So during the supernova event, the core of the star collapses in on itself and forms a very dense object. Imagine a marshmallow the size of a mountain. Now, squeeze that marshmallow until it's about the size of an actual marshmallow. It's so dense that if you could somehow stand on the surface of a neutron star, which you can't because you'd be squashed by gravity, you'd weigh as much as 1 billion elephants. That's kind of what happens to a star after its fuel runs out. This super dense leftover core is called a neutron star. So, you could say that a supernova is like a star's big send-off party, where it goes out in a blaze of glory, and a neutron star is what's left over after the party's over, like the empty pizza boxes and beer cans left after a wild night with friends. So, some scientists think that ISSN 15LH might be something like that. They think that it was a star that ran out of fuel and became a neutron star. Then, it spun so fast that it bursted out super hot jets of material. It's like when you spray water out of a hose. But the water is really, really hot. These jets can heat up the stuff around them and make the supernova even brighter than usual. But our mysterious friend was even brighter than that, so this theory might be wrong. But that's okay, we still have a few others. Another theory says that it was caused by the collision of two neutron stars. Such a collision would cause a real grand spectacle, with clouds of glitter and all that stuff. Another cool idea is that ISSN 15LH might have been caused by a supermassive black hole tearing apart a star that got too close. It's like if a hungry monster grabbed a hold of a tasty treat, But instead of eating it, it just tore it to shreds and made a huge mess. This one is probably the coolest, and lastly, the most boring explanation. This theory suggests that this mysterious object might not be as bright as we think it is. Instead, its light is being magnified by a galaxy cluster or some other massive object in space. It's kind of like if you put on a pair of glasses that make everything look bigger and brighter. So, these were all the possible explanations of this event. And if these mysteries weren't enough, then remember that scientists have no idea why this object could start glowing again. They thought that maybe it ran into some nearby gas that made it a bit brighter, but then that checked if it was the case and didn't see anything. So, 2-0 in favor of the weird bright thing. In other words, Assassin 15LH remains a mystery. It's still keeping astronomers on their toes and saying, "You thought you knew everything about supernovae. Think again, puny humans." And this isn't the only mystery in our universe. There are tons of things that scientists still can't explain. For example, have you heard of dark matter? No, it's not a group of Goth particles, but it's something even more mysterious. Dark matter is a substance that makes up about 27% of the entire universe. Yet, we can't see, touch, or taste it, even though it's hiding in plain sight. Scientists know that it's there because it has a gravitational pull on visible matter, kind of like how a good cheeseburger has a gravitational pull on me. The weirdest thing about dark matter is that we have no idea what it's made of. It's a mystery box, except we can't even see the box itself, and the mystery of dark matter still keeps scientists up at night. Another dark mystery is the elusive and enigmatic dark energy. It makes up about 68% of the universe, but we still have no idea what it is. Both of these are called dark because they don't interact with light or any other form of electromagnetic radiation. In other words, even though we know they exist, we can't see them directly. Can you imagine? We can only see about 5% of the universe. Who knows what else might be hiding there? One day, scientists noticed that the universe was expanding faster and faster over time, but it must be impossible, right? After the Big Bang, the expansion of our universe should gradually lose speed, like everything in nature. However, this wasn't the case. So, something must be pushing it, right? And that's how scientists came up with dark energy, a mysterious force that's thought to be pushing the universe and making it accelerate over time. But what causes it? Scientists still have no idea, and until we figure out what all these things are, they will remain one of the greatest mysteries of our universe. So, our mysteriously bright object isn't even one of the biggest puzzles. We still have tons of things to explain. Who knows what other secrets the universe is hiding from us? Either way, let's hope that one day we'll learn more about our world and answer these questions. In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So what is this mysterious blob? And how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for like hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light-years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man with his repulsor beams on full blast. Now, technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall towards the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called Periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole, and that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one, and while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers. That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows, maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now, that would be awesome. Well, well, my cosmic pal, do you ever feel like everything is just drifting apart? Well, your intuition may be right. It turns out something weird is indeed happening in the universe. Since the Big Bang, everything has been spreading out in every direction and getting faster every day. But here's the thing, not all galaxies are moving at the same speed. We have some seriously massive clumps of matter out there that are slowing us down. And there's one giant, mysterious gravitational anomaly that's been dubbed the Great Attractor. No, we're not counting me, though we share the same nickname. It's the mystery of mysteries, and it's been pulling us and all the nearby galaxies closer to it for billions of years. Scientists aren't certain what this Great Attractor is made of, but it's so powerful that it overcomes dark energy, which makes up about 2/3 of the universe. Dark energy is more or less like the universe's energy drink, pushing everything forward and giving galaxies a boost in their movement. So where is this thing? Hiding in the zone of avoidance, which sounds like a made-up town from a sci-fi movie, but is actually a real place in the universe. There's just so much stuff between us and the Great Attractor, stars, gas, dust, that we can't even see it. Some astronomers think this is just how the universe ends. Everything clumps together into one giant supercluster, and then boom, big crunch. It's like when you're trying to fit all your clothes into one suitcase, and it just ends up exploding everywhere. Now, before you start thinking that galaxies moving is no big deal, let me tell you that this isn't just any ordinary movement. You see, this thing called the Hubble flow dictates that galaxies should be receding from one another as the universe expands. But, as luck would have it, that's not what's happening. The Great Attractor is so strong that it even affects our own galaxy, hurtling us toward it at more than 1,000,000 miles per hour. I'll spare you the math, but if we spun around the sun at that kind of speed, our year would be a mere 18 days long. The Great Attractor was first noticed in the 70s, but our technology wasn't quite up to the task of seeing through the zone of avoidance. Nevertheless, X-ray technology has come to our rescue in recent years, and it has helped us piece together some of these hidden parts of the universe. What can this Great Attractor be, you might ask? We can only make assumptions at this point. The most likely solution is that it's a galactic cluster. They are basically the universe's version of a massive family reunion. These bad boys are held together by their own gravity, and can pack hundreds, or even thousands, of galaxies, along with a ton of hot plasma and sneaky invisible dark matter. Ooh, see. The X-ray data have revealed a plethora of distant galaxies that we previously didn't know existed. Not only that, but 2 new galaxy clusters have been found, the Norma Cluster and Shapley Supercluster. The Norma Cluster has a mass of roughly 1,000 trillion suns, and comprises thousands of galaxies. It's possible that the Norma Cluster is the reason for the Milky Way's high-speed hurtle through space, but it still can't explain the movement of thousands of galaxies around us. However, when scientists peered deeper through the zone of avoidance, they spotted the Shapley Supercluster. This behemoth of a galaxy cluster is the largest within 1 billion light years. It could explain the movement of galaxies in our sliver of the universe. More than 8,000 galaxies create a mass of more than 10 million billion suns. Most scientists have accepted that the Shapley Supercluster is most likely the force behind the Great Attractor. It lies in the region where the pull appears to be coming from, and logically, it seems to make the most sense. There's more though. Some researchers take pause at the proximity of the Shapley Supercluster to other clusters. Too many galaxies come together in various clusters there, openly defying the Hubble flow. Some experts believe that a large gravitational anomaly is a real answer to the Great Attractor. There have been theories ranging from a supermassive black hole, larger than anything we could possibly imagine, to some sort of life form making a mess in that corner of the universe. The Great Attractor is not the only weird thing we've stumbled upon in the universe, as you can imagine. Have you heard of the Red Rectangle? No, it's not a new dance move, but an amazing nebula surrounding a star called HD 44179. This star is a lot like our sun, but it's at the end of its life, and is spewing out gas and other materials to create this incredible structure. Some scientists think that the star might actually be a close binary, meaning it has a partner, and that there's a thick ring of dust around it. And even though we've got some ideas about how the Red Rectangle got its shape, scientists are not entirely sure. One thing we do know for sure is that the Red Rectangle is a type of nebula called a protoplanetary nebula. And when that happens, there will be a super hot white dwarf star left over, which will give off some seriously cool ultraviolet radiation and make the surrounding gas glow. As for its location, it's about 2,300 light-years away, hanging out in the constellation dubbed the Unicorn. Not all weird space objects are so far away from us in the universe. Some of them may be lurking pretty close to home. In January 2015, 2 clever astronomers made a prediction that a gigantic planet could be spying on us from our outer solar system. Now, before you start getting too excited, we should point out that they haven't actually seen this mammoth world yet. Their prediction is based on some pretty basic math and computer simulations, so there's still some debate about whether this prediction is true or not. But if it is, this planet, which scientists have nicknamed Planet 9, also called Planet X in the past, could be up to 10 times the mass of our own Earth and about the same size as Uranus or Neptune. What's really unusual about this mysterious planet is that its predicted orbit is extremely elongated, making it unlike any other planet we've seen before. In fact, It's estimated to be about 20 times further from the Sun than Neptune, and it takes between 10,000 and 20,000 years to complete just one full orbit. You might be asking yourself, how can anyone predict a planet they've never seen before? Well, these scientists noticed that at least 5 other smaller objects floating around in the distant parts of our solar system seem to be following similarly unusual orbits. By analyzing these orbits, astronomers worked out that there must be a big, undiscovered planet out there causing all the fuss. To figure out this mystery, astronomers will be peering into the universe's most powerful telescopes to see if they can spot this elusive Planet 9. However, it won't be an easy task, since an object that is so far from the Sun must be very faint and difficult to detect. Some astronauts have even experienced the Bermuda Triangle equivalent of space while passing through the South Atlantic anomaly. This is a region in Earth's magnetic field where 2 rings of charged particles come closest to our planet's surface. And as luck would have it, this area happens to be high above the South Atlantic. Computers can go haywire there, and astronauts can see cosmic flashes, possibly because of radiation stimulating their retinas. And it's not just poor astronauts who have to deal with this anomaly. Even the Hubble Space Telescope is unable to make observations when passing through this region. It's a real pain in the telescope's lens. So, what's the deal with this SAA? It turns out that our planet's magnetic field is not perfectly aligned to its rotation axis, which causes the 2 particle rings to tilt. And as a result, we end up with this region that's causing all sorts of trouble. Well, space is just one thing or another, isn't it? You get the last instructions from the team and get into your spaceship. It's the first spacecraft made on Earth that can move at a speed close to the speed of light. Your task is to visit the most unusual and terrifying places in space and send scientists detailed information about them. And so, your journey begins. Your spacecraft is accelerating, and you dash past the moon. In the distance, you see a small reddish planet. It's Mars. And look at that spectacular giant surrounded by a set of rings. That's Saturn. You wish you could have more time to explore this gas giant, but you have to hurry. You pass by beautiful stars. Some of them are luminous, others have a reddish hue, and some seem to be dimming. That's Sirius, the brightest star in the night sky on Earth. It's about 8.6 light years away from us, but you're traveling fast, and soon you see Polaris, aka the North Star, which is way further, 431 light years away. Sometimes you manage to spot tiny dots circling these stars. Those are planets. And then suddenly, you see nothing. At first, you're horrified. Has something gone wrong and you've accidentally entered a black hole? Has your equipment malfunctioned? Because it seems that at a distance of 700 million light years away from Earth, there's a hole. A blank void with no galaxies, stars, planets, or asteroids. You can see nothing. The void is a roughly spherical region about 330 million light years across. Our home Milky Way galaxy could fit there billions of times over. And then, it dawns on you. What you're looking at is the mysterious Bot's Void. It lies about 700 million light years away from Earth. In the constellation of Botas, the herdsman driving the plow around the North Pole. At first, this void was called the Great Nothing, but later, it was given its current name. Now, we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are ginormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light years wide. The Buddha's void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, all the matter in the universe was packed together quite tightly. Astronomers even think it was something like a uniform soup. But pretty soon, random quantum fluctuations started distributing this matter. Some areas became denser. As a result, their gravitational pull became stronger, and they began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. After staring at nothingness for some time, you decide to explore other space objects and start the engine of your spacecraft again. There's one kind of space formation you've been looking forward to seeing: nebulas. Those are gigantic clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. Sounds familiar, doesn't it? One day, this mass becomes so big that it collapses under its own gravity and forms new stars. So, you decide to visit some of the most beautiful nebulas out there. And you start with the Butterfly Nebula. This butterfly's wingspan is more than 3 light years, and the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 250,000 C. It means it was formed from a gargantuan star, likely more than 5 times the size of our sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. The next place you decide to visit is the Eskimo Nebula, 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and got its name for a reason. Its double shell formation looks like a person's face hidden in a padded hood of a winter jacket. But in reality, this parka is a disk of material with a ring of comet-shaped objects, and the tails of these objects stream away from the star at the center of the Eskimo Nebula. The bizarre orange streaks in the outer part of the cloud stretch light years away in all directions. As for the Eskimos' face, even though it resembles a ball of twine, in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Your next destination is the Ring Nebula. At first sight, it's a giant cloud of dust and gas surrounding an old, almost extinguished star, which does look like a ring. But astronomers say the nebula isn't a bagel. It's a jelly-filled donut. The deep space colorful object, more than 2,000 light-years away from Earth, is actually a ring that wraps around a blue, ball-shaped structure. Each end of this structure sticks out of the ring's opposite sides. Now, you can head to a place called the Pillars of Creation. You find it more than 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars, just 5.5 million years old, space babies. Once, the Hubble Space Telescope managed to take an image of severed and dark silhouettes near the nebula's center, and now you can see them with your own eyes. Those are the so-called Pillars of Creation, an active star-forming region. And since you've already visited a star-forming region, why don't you drop by a living fossil galaxy? For example, DGS-at I, it's as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It can mean that DGS-at I was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. The next stop on your space sightseeing tour is the Black Widow pulsar. Just like its spider namesake, This rotating neutron star is munching on its partner, a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. Oh, look at this! That's a stellar nursery in the constellation of Centaurus. But even though this place might be called nursery, it's anything but peaceful or safe. This region, made up of hydrogen and newborn stars, is located in a nebula in the constellation of Centaurus, around 6,500 light-years away from Earth. The intense energy these baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful that it's eating away dark clouds of dust, and they're disappearing like lumps of butter on a hot frying pan. You're continuing your journey when you see something absolutely amazing: a cloud of water floating in space. To be more precise, it's a cloud of water vapor surrounding a supermassive black hole, 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. Prepare for blastoff because there's some exciting news from NASA coming our way. Care to look into the fascinating world of Saturn's moon Titan? NASA's groundbreaking Dragonfly rotorcraft lander is set to take off in 2027, looking to explore this mysterious space object. Now, let me introduce you to Titan. It's an icy celestial body with an atmosphere filled with nitrogen, and it might even have an underground ocean. Titan is also home to rivers and lakes that flow on its surface. But guess what? They're not filled with water like our lovely planet. They have methane instead. Now, let's check out Titan's celestial credentials. It's not just any moon, it's the second largest in our entire solar system. It's only 2% smaller than the biggest moon we have hanging around our neighborhood, which is Jupiter's Ganymede. Titan's size even puts Mercury to shame. And did I mention that its atmosphere is 4 times denser than that of Earth's? Thanks to Titan's lower gravity and thick atmosphere, Dragonfly is the perfect robotic companion to uncover its hidden treasures. Let's move on to Dragonfly, the star of NASA's upcoming mission to Titan. This cosmic drone is not your average explorer. Equipped with a full array of interesting gadgets, Dragonfly is like a flying laboratory, ready to uncover more secrets of Titan. It's the first interplanetary rotorcraft lander probe, designed to take us on an epic journey of discovery. And don't let its name fool you. Dragonfly won't just buzz around aimlessly. This technological marvel is able to glide for several miles between different locations on Titan's surface. Think of it as a cosmic Uber service for scientists. And speaking of technology, Dragonfly is carrying some seriously cool equipment. It will feature the drill for acquisition of complex organics, Draco instrument, which will help us scoop out material from Titan, while the Dragonfly mass spectrometer, DRA-MS, will analyze what these samples are made of. But how did we stumble upon Titan? It was March 25th, 1655, when a Dutch astronomer was out there with his telescope, exploring the cosmos. Lo and behold, he spotted something amazing. It was Titan, the biggest moon of Saturn. Fast forward almost 300 years to 1944, when another cool astronomer jumped into the picture. He was doing some experiments with light when he figured out that Titan actually has its very own atmosphere. There's more to this story. In 1979, the Pioneer 11 spacecraft decided to take a joyride through the Saturn system. It confirmed all the cool things scientists had previously speculated about Titan, like its temperature and mass. However, there was one tiny mistake. Those sneaky scientists thought Titan might be the biggest moon in the entire solar system. Oops, wrong guess. Nevertheless, Titan had this mysterious dense atmosphere that kept everyone on their toes. Now, let's zoom in on the 1980s, when the Voyager 1 and 2 spacecraft make their grand entrance. These cosmic explorers flew past Saturn, and they wanted to get a good look at Titan's surface. That's when Titan decided to play a game of hide-and-seek with them. Its hazy atmosphere made it impossible to see what was going on down there, so all the Voyagers managed to capture were images of a lonely orange world. However, they did spot a fancy blue haze hanging out in the upper atmosphere. Things started to get really exciting in the 1990s. The Hubble Space Telescope joined the party and decided to take some cool snapshots of Titan using special infrared light. This clever device managed to pierce through the haze, and voila! The Hubble images revealed differently colored areas on Titan, almost like a giant cosmic chessboard. We now know that there's even a bright spot as wide as Australia down there. However, despite these fantastic pictures, the mystery of what lay beneath Titan's haze was still unsolved. It was 2004 when the stage was set for Cassini and its European sidekick, the Huygens probe. They were like the ultimate dynamic duo, ready to take on Saturn. Cassini started orbiting the ringed planet and immediately focused its attention on Titan. The big moment finally arrived. On January 14, 2005, the Huygens probe pierced through Titan's atmosphere. During its descent, Huygens collected all sorts of amazing data, snapping images and analyzing the atmosphere. The probe then transmitted this valuable information back to Cassini, which, like a cosmic courier, sent it to us eagerly waiting Earthlings. Over the next 13 years, Cassini flew close to Titan over 100 times, using all sorts of fancy instruments to get a good look at the moon's surface and atmosphere. Scientists could finally confirm that Titan had clouds, lakes, and rivers, and there was also some rain pouring down its surface. Thankfully for us, Titan isn't the only moon in our solar system that could technically harbor life. Take the wondrous moon of Neptune called Triton. For starters, it's the largest moon of Neptune, but it's also a real oddball. Among the many moons out there, only 5 are known to be geologically active. And guess what? Triton is proudly part of this exclusive club. It loves to show off its geysers, which spew nitrogen gas. Picture Triton as a fashionista in an icy ensemble. Its surface is mainly frozen nitrogen, giving it a chill, frosty vibe. You might want to bring a warm coat if you ever visit. Now, you may be wondering how Triton manages to keep warm in such a frigid environment. Well, it's got a secret weapon called tidal forces. Imagine Triton and Neptune engaged in a cosmic dance, creating gravitational friction. This dance seems to generate some heat, helping to warm up Triton's waters. With all this talk about heat, you might be getting excited about the possibility of life on Triton. However, finding life on this moon is about as likely as finding a unicorn riding a skateboard. Voyager 2, the only mission to ever fly by Triton, made its journey back in 1989. And if you're hoping for another mission to Triton anytime soon, well, let's just say the stars aren't aligning in our favor. Literally. The window for a mission to Triton opens up only once every 13 years, because our planet and Jupiter need to be perfectly aligned for the landing to work. Scientists would use the gravitational pull of the largest planet in our solar system to safely deliver a probe on Triton. Now, let's address the elephant in the room, or should I say the polar bear. It's so cold on Triton that hopes for life to survive unfrozen are about as slim as a toothpick. Sorry, potential little microbes. You might need a few extra sweaters to set up shop down there. Even though Triton may not be the most welcoming place for life, it's still a celestial gem worth exploring. Scientists also believe Triton wasn't always a part of Neptune's crew. As it turns out, Triton was most likely just minding its business, hanging around aimlessly in the distant Kuiper belt. Along came Neptune with its mighty gravitational pull, and snatched Triton right out, officially making it a moon of its own. Just like our trusty satellite, Triton is also stuck in a permanent face-off with Neptune. One side of Triton always has its eyes locked on the planet. As for this amazing moon's fate, things aren't looking so good in the long run. It's already getting closer and closer to Neptune every day. Why is that, you might wonder? The problem is with those tidal interactions, which are playing some cosmic tricks on Triton. They're causing its orbit to wither away, like a slow-motion dance towards Neptune. Scientists predict that in about 3.6 billion years, Triton will cross an invisible boundary. If these current calculations are correct, there are two possible scenarios. It'll either have a collision with Neptune's atmosphere, or it might just break up into tiny pieces. If the latter happens, an all-new ring system would form around Neptune, just like the one we see around Saturn nowadays. Triton is not the only satellite that might end up this way. Phobos, one of the Martian moons, is likely to disintegrate too, and sooner, in 30 to 50 million years. Empty space is not really empty. At least that's what quantum field theory says. It's actually filled with tiny vibrations that can turn into virtual particles if they have enough energy. These virtual particles can produce packets of light with low energy called photons. Now, there's something every black hole has: an event horizon. It's a point of no return. That means once something crosses that point, it can never get away, not even light. And there's an insanely strong gravitational force around the event horizon. Black holes survive by gobbling up gas and stars around them. In most cases, a black hole has a swirling disk of material that surrounds it, called an accretion disk. It glows brightly as all those things that come too close to an event horizon get heated up and torn apart before the black hole swallows them all. As material comes closer, it starts to travel and move faster and faster, going all around the black hole. This makes the accretion disk glow and, at the same time, outlines the shadow of the black hole, which is basically the very event horizon we're talking about. Black holes might even want to hide, but they do so awfully badly. According to Einstein's theory of general relativity, gravity bends and warps space and time. It means that the closer you come to this extremely powerful gravitational pull around the black hole, the more twisted space and time around it become. That's what Stephen Hawking was talking about nearly 50 years ago, 1974. He also suggested that if these particles find a way to escape a black hole, they steal some of its energy, and because of these thieves, the black hole loses its energy as time goes by until it at one point completely disappears. He suggested that black holes release energy in the form of thermal energy, or heat, which is called Hawking radiation, and this radiation doesn't carry any information. It means that when a black hole evaporates, it destroys all information it had about the star that created the black hole. That way, we can't know what really happened. And it's kinda confusing because the laws of quantum mechanics say the information can't be destroyed. This conflict is something we call the Hawking information paradox. According to Hawking, all this information isn't really lost, but is stored in a cloud of all those zero-energy particles that surround the black hole. He called that soft hair. Now there's this new study as a possible solution to this paradox. Maybe Hawking radiation is non-thermal? Instead of just releasing plain heat, it's possible the black hole sends out a message in the form of radiation. This message contains important information about the black hole's past, the stars that formed it, and other details we thought were lost forever. It's like a secret code that tells us all about the history of the black hole. But let's go back to Hawking's theory, where a black hole can eventually disappear. It says that not only black holes produce Hawking radiation, any object with enough mass can. Researchers actually studied a process called the Schwinger effect too. It's when an electromagnetic field creates strong distortions, and in that way, forms matter. They applied this idea to Hawking's theory of black hole radiation. What they found is that the radiation Hawking predicted can actually be created in places with different levels of gravity, not just around black holes. Here's the key. When there are massive objects, like stars or planets, they create a curving effect on space and time. This curving is there because of their strong gravity. Even if you're far away from a black hole, there's still some massive object somewhere around that creates the curvings of space, which can make you feel like you're in that twisted space. It can create radiation, similar to what happens near black holes. It means that not only black holes can slowly evaporate, other massive objects in the universe can also lose their energy in the same way. If this is true, the energy of everything in the universe will slowly be drained away in the form of light particles. That means everything and everyone, including stars, planets, black holes, and us, share the same destiny, and will all eventually fade away. This sounds scary at first, but even if this theory is true, it's not going to happen anytime soon. It would take way longer than the current age of the universe for a supermassive black hole to completely disappear. So, in the way we measure time, black holes are basically eternal. And stars could last even longer since many black holes formed after some giant star collapsed upon itself. Some others belong to a group called primordial black holes. Hawking, who became famous for talking about black holes, mentioned those ones as well, and the theory says they probably formed spontaneously in the early universe, not long after the Big Bang happened. Hawking realized that primordial black holes could have different sizes, from very light to very heavy. Really small ones would have disappeared by now, because of Hawking radiation. There's a pretty cool idea that these primordial black holes could be dark matter. It's a mysterious substance that scientists think exists in the universe. It doesn't give off or reflect light, so we can't see it directly. Scientists think dark matter might explain why stars and galaxies move in strange ways. But we still don't have the tools yet to confirm whether these black holes really exist, or if they're actually made up of dark matter or not. Hawking also explored the idea that our universe is just one of many universes. It's a concept called the multiverse. Some scientists believe it could be that any situation you can imagine in your life is happening somewhere in some other universe. Hawking didn't agree with that, so in his final paper, he proposed a new mathematical framework that made the multiverse finite instead of infinite. This means that there would be a limited number of universes rather than an infinite number. Another thing that's hard to test and prove, but at least he left us with something to think about. Believe it or not, time travel is not that impossible according to the laws of physics. Scientists have equations that suggest we could have something called closed time-like curves that might allow us to go back in time. Imagine going back to the most embarrassing moments of your life. Knowing what would happen, you could avoid them. But here's the tricky part. Going back in time could cause some big problems. It could create situations where things would happen in a way that doesn't make sense. Imagine you're walking down the street and meeting your younger or older self, or accidentally changing things that have already happened. Hawking was talking about this part too, and these are all things that made him concerned about time travel. He made a guess called the chronology protection conjecture. He suggested there might be a rule of nature that stops time travel from happening because it could create all these strange and confusing situations where we would just go back, fixing our wrong decisions rather than living in the present. Until we discover traveling through time without causing such disruptions, I guess all we're left with are life lessons and learning from our mistakes. In his last years, Hawking talked about the future of humanity, and we still don't know if he was totally serious. He mentioned a special particle called the Higgs boson that could cause a big bubble that could gobble up and eventually even destroy the universe. He also mentioned things like beings from other planets coming to Earth and conquering us, or robots becoming smart enough to take over the world. Some of his ideas turned out to be true, and time will tell if it will be the same with the others. Imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth Twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the Sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in incredibly hot temperatures. No wonder it will take a long time before we'll be able to stand on this planet. Up to 3-sec pause. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days. Basically, a half a year. Just like with Venus, a day there takes much longer than a year. Since it's the closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it will be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's north polar region, especially at those sunlit yellow spots inside craters. These are indications of water ice. Turns out, water is much more common in space than we thought. Sucker 3-sec pause. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But turns out, Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons. Standing at a staggering height of about 13.6 miles tall, it's even taller than Mount Everest. It was formed by the eruption of low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out, they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Marsquakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar yet different the planets are. Achpawar 3-sec pause. Saturn's iconic rings might hold a secret linked to Earth's ancient past. The rings are composed mainly of ice particles and debris, and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons, or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. While Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune also have their own sets of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out. The magnificent hexagon at its north pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think that it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. 5. 3 sec pause. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that has been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But, compared to Earth, the scale of these auroras is incredible. Nothing like we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the 8th and farthest planet from the Sun, also has its own great dark spot. Just like with Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant, and just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 1,200 miles per hour. What a drama queen. But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like, in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover more interesting things in outer space in the future. Shop Pirate. Hold onto your telescope, space rat. Scientists have made an astonishing discovery. They've found the ancient heart of the Milky Way galaxy. But what is this ancient heart? And what does it tell us about the history of our galaxy? Let's find out. Ketchunau retroskau, chatue puri say, our chassis statues, chatis errors, chain site service. Bait chep visau, propai, shitwites your ain't thou. Pirate, is that it? Don, yes, and thank you, Captain Jack. Pirate, my pleasure. He leaves. That's right. What can I say? He's a space pirate. The Milky Way isn't just a candy bar, but a majestic spiral galaxy that's home to billions of stars, planets, and other celestial objects. And it's all spread out over a distance of about 100,000 light years. The Milky Way has a distinct shape, with a central bulge and spiral arms that extend out from it, kind of like what I look like from the side. The spiral arms are like the suburbs, where the stars are more spread out and the neighborhoods are quieter. They're made up of gas, dust, and stars that all move together in a circular pattern around the center. In between the spiral arms, stars, there are vast regions of empty space, known as interstellar space. Here, you can find wispy clouds of gas and dust, as well as some of the most spectacular sights in the galaxy, like massive star-forming regions and colorful nebulas. The Milky Way is also surrounded by a huge halo of dark matter, a mysterious substance that we can't see but can feel its gravitational effects on the galaxy. This halo helps to hold the galaxy together, and it extends out much farther than the visible parts of the Milky Way. And finally, there's the center. Here, the most action happens. In the center of the Milky Way, there is a supermassive black hole, which is about 4 million times more massive than our Sun. Sagittarius, a star. This black hole is responsible for some of the most energetic events in the galaxy, like the emission of powerful jets of energy. Remember the famous first photo of a black hole that flew across the internet? It was Sagittarius, a star. We managed to capture this black hole because it's the closest one to us. All in all, the center of the Milky Way is full of stars that are tightly packed together, forming a dense cluster. And it was here that astronomers recently made a new epic discovery. The heart of our Milky Way galaxy has been found. And boy, oh boy, is it an old-timer. Hey, who are you calling an old-timer? A team of brilliant scientists has found a cluster of 18,000 stars, born right after the Big Bang. Together, they form the ancient nucleus of our Milky Way. These stars date back to a time when our galaxy was just a wee little baby, a mere collection of proto-galaxies, huddling together to form a bigger and better thing. The scientists called it the poor old heart of our Milky Way. Can you believe it? These ancient stars are over 12.5 billion years old. And yeah, maybe they account for a mere 0.2% of our galaxy's total mass. But that doesn't matter. These stars are the building blocks that formed the core around which all the other stars and planets took shape. But how exactly did they become this heart of the galaxy? How did they form? And how did we discover all that? To answer these questions, we'll have to plunge into the past. A very, very distant past. Once upon a time, almost 14 billion years ago, there was the Big Bang. Our universe was born. At first, it was incredibly hot, but as time passed, things started to cool down, and tiny pockets of gas began to clump together due to the force of gravity. These were the first galaxies. The Milky Way is one of these galaxies. It also started as a small clump of gas and dust, but over time, it began to take shape. The very first stars, protostars, began to form within the clouds, and their gravitational pull caused more stuff to come together. This process continued for millions of years until the Milky Way was formed. But to learn the history of our galaxy in more detail, we need to find these protostars. And this is far from an easy task. Researchers have discovered the ancient heart, using a neural network to analyze data from the European Space Agency's Gaia mission. The Gaia telescope is a space observatory launched by the European Space Agency in 2013. Its job is to map the position and movement of more than 1 billion stars in the Milky Way galaxy. 1 billion stars. That's like counting every grain of sand on a beach. It's a huge job, but Gaia is up to the task. So, how do they do it? The telescope has 2 cameras that take pictures of the sky at the same time. These cameras are so powerful that they can detect stars that are 1 million times fainter than those visible to the naked eye. Gaia takes many pictures of each star, and this allows us to track their movements with incredible precision. Thanks to the data collected by Gaia, astronomers are learning more about the structure and history of the Milky Way. They're discovering new details about the stars, including their ages, temperatures, and chemical compositions. Gaia is also helping astronomers search for exoplanets, or planets that orbit stars outside of our solar system. So, for this research, astronomers used Gaia and the most accurate 3D map of the Milky Way ever compiled. They had to analyze around 2 million stars to find the primordial group. One way that astronomers can determine the age of stars is by looking at its brightness and temperature. This way, they study a brief phase of stellar evolution known as subgiants. But imagine searching through the huge center of the Milky Way for the tiniest group of stars that are older than 12.5 billion years. This is like searching for a needle in a haystack. Luckily, they had a trump card up their sleeve: metals. You see, in the early universe, the cores of these stars were so hot and dense that they were able to smash atoms together to form heavier elements. These heavier elements are called metals in astronomy, even though they're not really metals like the ones we're used to. The more massive the star, the more metals it can create during its lifetime. When the life of the first stars came to an end, they made a big boom and scattered these metals all around. Metals mixed with other gases and joined the newborn stars, and so on. As time passed and the universe got older, more and more generations of stars formed, each one richer in metals than the last. Can you guess what that means? The older the stars, the less metals they should have. So now it was time for some galactic archaeology. The team taught the AI to find the metal-poorest, most ancient stars, and it succeeded. It found a huge cluster, and all of them were within 30,000 light-years from the center of the Milky Way. Then, they separated out the stars that form the ancient heart from the stars that originated in a dwarf galaxy, and finally, we were left with the original stars around which the Milky Way grew. This discovery is incredible. It reveals the remnants of the Milky Way's earliest history. It turns out that simulations of the Milky Way's formation were spot on. The old stars existed just where they were predicted to be. Just imagine, the stars that remember our universe as a baby are still hanging out in the center of our galaxy. Isn't that mind-boggling? So why is this such a big deal? By studying these ancient stars, scientists have discovered some incredible things. For example, they've confirmed that the Milky Way's core began its life stationary and only picked up rotational speed as it grew. We might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry, Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it has been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It is also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 20 times farther out than Neptune, which sits at about 4.5 billion kilometers. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-discovered world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets, like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 22 billion kilometers. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that is a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there throwing these objects off course, and that something could be a planet chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planet discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by the pull of an undiscovered planet. And just like that, we discovered Neptune. The year is 2021, and there is all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost. In the dark outer reaches of our solar system, enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They are putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 8 meters fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomena occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to interference from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth, and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So, yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. During the recent years, scientists made 2 breakthrough discoveries about our universe. Thanks to new technologies, we've looked into the distant past, and we've learned something that can change our understanding of the universe forever. What are these discoveries, and what do they mean to us? Let's find out. Recently, we unveiled the first color image from the James Webb Space Telescope. It's a mind-bending photo capturing thousands of ancient galaxies. This oldest documented light in the history of the universe dates back over 13 billion years. That's just 600 million years after the Big Bang! It's like getting a sneak peek into the universe's baby album. But that was just the beginning. Astronomers were expecting to see some tiny young galaxies, but what they found was a real surprise. Impossibly early, impossibly massive, and all that from just a tiny red dot. The lead author of the study, Ivo Labbé, was working at the computer as usual, and suddenly he got 2 numbers. Age, 13.1 billion years. Weight, 100 billion stars. When he realized what that meant, he nearly spit out his coffee. But that red dot was just the beginning. The next day, they found 5 more galaxies just like this. Turns out, these 6 massive galaxies are as old as the Milky Way itself. The entire research team was in disbelief. They were like, wait, what? These guys couldn't be that mature so early in time. Did we make a mistake? But nope. The James Webb Space Telescope, the new cool guy on the space block, just has some serious skills. It can see through dust clouds with its infrared vision and spot galaxies that were previously invisible. Move over, Hubble. There's a new stargazer in town. But why has it shaken things up so much? Because this discovery affects our understanding of how galaxies formed. Let's try to explain. A long time ago, 13.8 billion years ago to be precise, our universe was born. It was chilling out for a while, and then it started to form the first galaxies. And these galaxies were full of gas and dust. Eventually, this gas started turning into stars. Some galaxies were more massive and had more stars, and some were lighter and had almost no stars at all. In any case, they all grew gradually. The stars in them were born slowly and smoothly. That's how our current models explain this. But these new observations from the James Webb Space Telescope show an unexpected surprise. Looks like even in the early universe, our ancient friends had lots of stars. More than what we would ever expect. If that's the case, then these galaxies are like the overachievers of the universe. They skipped the small and gradual growth phase and went straight to being giant universe breakers. According to our current cosmological model, they shouldn't even exist. But they do. So it looks like after the Big Bang, The stars were forming much faster than we thought. As you can see, these universe breakers are really living up to their name, causing a potential total consensus among scientists. The universe was like, hey, I'm about to flip cosmology models upside down. But let's not jump to conclusions. There are many theories that could explain these mind-boggling discoveries without breaking the standard model. For example, maybe the light we're seeing isn't coming from stars at all, but from the swirling disks of doom around supermassive black holes. These colossal cosmic beasts can gobble up matter and spit out a dazzling light show. And James Webb Telescope's keen eye is picking up on these enigmatic accretion disks like never before. Or maybe these galaxies could be playing hide and seek with us. Maybe there's more to the story that we haven't seen yet. After all, the universe is vast and mysterious, and we've only just begun to scratch the surface. And whoa. We really need to slow down here. Before we even try to explain all this stuff, we need to confirm whether these ancient galaxies really are that old. Although even if they're actually just supermassive black holes, it still shows an astounding change. We'll have to wait about a year to find out. One thing's for sure, the James Webb Space Telescope has definitely taught us a valuable lesson. Expect the unexpected. And this is just the beginning of unexpected. Ivo Labé's team wasn't the only one who made such a huge breakthrough. There's also a team that claims that they've unlocked the secrets of the universe's past, and that's worth 2 Nobel Prizes. Move over, James Webb Space Telescope, because this discovery came from an antenna that's smaller than a fridge and costs less than $5 million. Talk about space bargain hunting. The astronomers caught this signal that showed some surprises. It was coming from the earliest stars of our universe, back in the days when they were just beginning to twinkle. Say hi to our celestial ancestors again. Now, the signal was pretty weird. The temperatures were unusually low, and there was a pronounced wave that left astronomers scratching their heads. What could be causing all this? Well, there's a theory. Dark matter may have been at work, and if that's the case, then we can really be on the verge of a great discovery. Imagine you're looking at the night sky filled with stars, but there's something else there that you can't see. It's like an invisible cloak that covers the entire universe. Scientists call this mysterious stuff dark matter. Dark matter is like the ghost of our world, Xiaoru. It doesn't emit, absorb, or reflect any light. We can't see it with telescopes or our eyes. That's why we call it dark matter. But if we can't detect it in any way, how do we know it exists? Because of its gravitational pull. One day, we noticed that our understanding of how galaxies were created was incorrect. According to our calculations, they should have been some chaotic gas, but something held them together, turning them into spirals, like some kind of invisible glue. Then we thought, maybe this invisible glue really exists. If the moon was invisible, we would still suspect that it exists somewhere because its gravity affects the tides on Earth. This is also the case with dark matter. Its gravity influences the motion of galaxies and other cosmic objects. In fact, dark matter makes up a huge chunk of the universe, about 27% of it. Moreover, the normal matter we can see, like stars, planets, and galaxies, only make up about 5% of the universe. Scientists are still trying to figure out if dark matter exists and what it can be made of. Some theories suggest that it could be made up of exotic particles that are different from the particles that we're used to. Others think that it might be some kind of weird, undiscovered form of matter that doesn't interact with light at all. Anyway, it's an intriguing mystery, and if we ever confirm the existence of dark matter, our understanding of our world will change forever. So now you can understand why the excitement in the scientific community is palpable. If this discovery is confirmed, then we will get the first real proof of dark matter. This discovery may be even more important than the Big Bang itself because, as astronomers put it, we are made of star stuff, and so we are glimpsing at our origin. But of course, we still have to wait and explore all this in great detail. In science, one should never rush to conclusions. And while scientists study this stuff, we'll be here, on the edge of our seats, waiting for the next space blockbuster to unfold. The universe never ceases to amaze us with its wonders. Who knew that such a small and humble antenna could unlock such cosmic secrets? It just goes to show that in the vastness of space, even the tiniest discoveries can have the biggest impact. Keep looking up, and who knows what other cosmic surprises are waiting to be uncovered. There's a chance that our entire Milky Way galaxy is located in the so-called space void. It's a region where there's relatively little matter as compared to other corners of the known universe, and it's much less dense than it is elsewhere in the universe. In other words, we might exist in an air bubble in a cake. If that's true, it would mean that we're even lonelier than we thought. In our universe, all the galaxies are constantly moving away from each other. In order to understand how far they move away, scientists use something called the Hubble-Lemaître constant. It's like a speedometer, but for galaxies. However, there's a cosmic mystery called the Hubble tension. It's challenging what we know about the universe's expansion. Scientists used to consider the Hubble-Lemaître constant a reliable guide, but our recent observations question this reliability. The speeds we see in real life don't match up with the distances we calculated and expected. They aren't sure why these measurements don't add up. Researchers followed the moves of supernovas and saw that the universe seems to expand faster around us than it does overall, as if it's actively avoiding us specifically. After considering this, they began to assume that we all might live in a cosmic void. Cosmic voids are vast, empty spaces between galaxies. They make our entire world look like a big sponge. Let's go back to the beginning, just a fraction of a second after the Big Bang. Right after the beginning of everything, the universe was a hot, compressed plasma. It only had very tiny variations in density called quantum fluctuations. After the Big Bang, the universe began to expand. Those quantum fluctuations grew together with it, creating regions of varying matter density. Because of that, the universe didn't expand everywhere uniformly. Instead, little claps of matter began to gather together over a long time, creating massive structures. Galaxies. Galaxies are arranged in huge walls and filaments with enormous gaps in between. And these gaps are the voids, also known as dark space. These voids aren't truly empty. In fact, they actually hold more than 15% of the amount of matter found on average throughout the entire universe. They still contain gas, dust, dark matter, and even stars and galaxies. However, they have less density than regions with galaxies, about a tenth of the average matter density, which is why we consider them nearly empty. Usually they have a diameter ranging from about 30 to 300 million light years. That is an enormous distance, even on a space scale. For comparison, most planets and nebulas we've found so far have a distance of hundreds and rarely thousands light years away from us. In the case of voids, if you were in the middle of one, it would just look like seemingly eternal darkness. The closest stars would be so far away that they would be almost invisible to you. Some of them are especially large. They're known as supervoids. The largest known one was creatively named Giant Void. It's so big, it's impossible for us to even imagine. 1.5 billion light years away, with a diameter of 1 to 1.3 billion light years. Yes, it's basically a giant dark vacuum, but even this giant vacuum isn't entirely empty. The giant void houses 17 separate galaxy clusters within its expanse. However, it might not be the biggest emptiness in our world. There's this thing called the CMB cold spot. It's this unusually large and chilly area of our universe that we saw through the microwaves. It really stood out on the map of our universe with its unexpectedly low temperatures, and scientists have spent many years trying to figure out what this thing is. In 2015, scientists proposed that this place might be a supervoid, and probably the largest one ever. Being even more original with this one, they called it the Great Void. If it's true, this place would be an emptiness about 1.8 billion light years in diameter, about 1,000 times larger than typical voids. Not everyone thinks that it's possible, so scientists keep arguing over this one for a while. There's another interesting theory going about this place. One researcher suggested that this place might have been a trace from our collision with a parallel world. It's a pretty bold hypothesis, But, unfortunately, there's no way for us to confirm or deny it with our current technologies. In any case, as the universe expands, these voids will grow, and the walls connecting galaxy clusters will stretch and break. Eventually, the voids will merge, leaving gravitationally bound galaxy clusters as islands in the expanding emptiness. In other words, sooner or later, the great emptiness will consume everything in our world. So, it turns out, we might be a rare occasion in a supervoid, one of the 15% of matter. This would explain why we're surrounded by relatively few galaxies. This discovery, if true, challenges the standard model of cosmology which we created with Albert Einstein's help. It would mean that gravity in general behaves differently than what we expected. According to the standard model, such a significant underdensity shouldn't exist. Because of that, scientists will have to explore and consider this idea thoroughly. It might just challenge our very basic understanding of physics. The scientists called this the local hole. The discovery of the local hole may hold clues to explaining the Fermi paradox. Maybe in this specific part of the universe where we hang out, the chance of intelligent life developing anywhere nearby is very low. Perhaps all the sentient beings hang out somewhere beyond our super void. But that doesn't mean that we should lose hope, or that life anywhere nearby is impossible. In fact, life in the universe might be much more common than we previously thought. We know that the inner planets, like Mercury and Venus, are inhospitable due to extreme conditions. However, Venus looks interesting because, even though it's a crazy toxic planet, scientists believe that it was very Earth-like in the past. It could have even hosted life. Unfortunately, it was too close to the sun, and all the nice conditions evaporated over time. But there's a possibility of microbial life surviving in its high-altitude clouds. Mars, a cold desert, also might have been a friendlier place in the past with rivers and lakes. Though now it lacks a protective atmosphere, ancient life might have existed there. In that case, it would leave potential fossils, and underground microbes could still survive. We've discovered some signs of them, but are still debating whether this stuff was truly organic or not. The gas giants, like Jupiter and Saturn, and ice giants are not ideal for life, but their moons offer hope. Europa has an ocean beneath its icy surface, making it a potential hotspot. Enceladus releases water into space, carrying complex molecules that hint at interesting possibilities. And Triton is especially unique. It has liquid bodies on its surface, rivers and lakes of hydrocarbons. While its frigid temperatures aren't great for life, scientists ponder if it might host life with a different kind of chemistry. However, it will take us decades to check all these celestial bodies and study them properly. We haven't sent anything so far since the times of Voyager 2, but if we're lucky, we might explore our solar system during the 21st century. In any case, there's a lot of potential for life, even in our solar system alone, not even mentioning all the planets and galaxies we've found nearby. Our estimates suggest that the observable universe, the one we can see, might host around 5.3 trillion habitable worlds. One of the most likely candidates so far is Kepler 186f. It's a potential Earth-like planet, just 10% larger than Earth. This planet orbits a red dwarf star, which is a star a bit dimmer, colder, but more long-living than our Sun. And it's only about 490 light-years away, which may sound like a lot, but remember what distances we've discussed with supervoids. So, even if we really are in a supervoid, we're still lucky to have many galaxies and planets around. And if one day we'll find a way to travel through the universe, leaving the local hole probably wouldn't be a problem. The moon is rusting, and chances are it's happening because of Earth. You'd say that since they're more than 370,000 kilometers apart, 384,400 kilometers, they can hardly directly influence each other in such a way, but they do actually have a special connection. The moon affects our home planet as well, and you can see it while observing ocean tides. As Earth rotates, the moon's gravitational force pulls the water on the nearest side of Earth. It creates a bulge. At the same time, another bulge forms on the opposite side. Because our planet rotates, and it causes a centrifugal force. And then, the planet continues to rotate underneath these bulges, which is why we have 2 low and 2 high tides every day. Plus, the moon wobbles every now and then, every 18.6 years, tilts more or less, and causes changes in ocean tides. 1-3 sekpause. And, in return, Earth's atmosphere is making our satellite rusty. Rust is that reddish substance you see on old gates or nails. Oh, and you know Vermilion Cliffs and the Grand Canyon. They also have that specific red color thanks to rusty iron in the rocks. It forms when iron reacts with oxygen and water. Rust is common even on Mars. The planet's trademark color comes from the rust that's been there for a very long time. That's how the red planet got its nickname in the first place. Normally, you wouldn't say the moon is a place that would rust that easily since it's dry and doesn't really have an atmosphere. But a spacecraft, JPL Moon Mineralogy Mapper, studied the moon back in 2008 and detected spectra, wavelengths of light, that were reflecting off different surfaces of the moon. That's why it could analyze the lunar surface better. The data it brought showed that the lunar poles had different compositions than the rest of the moon. They had rocks that contained a lot of hematite. That's a specific type of iron oxide, or simply rust. Oh, 2-3 sekpause. No one expected that because there shouldn't be so much rust on the moon, considering the conditions there. But we know that there's some water up there on the surface of our satellite. That's why a few new theories popped out about different minerals the moon could be hiding. It's possible that they formed because water had reacted with the rocks. For iron to get this rusty hue, it needs something we call an oxidizer. That's a molecule that removes electrons from materials like iron, such as oxygen. But the solar wind keeps hitting the moon all the time, and it brings hydrogen with it. And hydrogen has the opposite effect. It gives electrons to other molecules. Earth has its shield from the solar wind. It's our magnetic field. But the moon doesn't have such protection, and because of that, rust shouldn't be able to form on its surface. But this process still happens, and it could be Earth's fault. Start 3 sekpause. The moon itself doesn't have an atmosphere that could provide enough oxygen for iron to rust, but apparently, our planet is generous enough to donate some of its own atmosphere. The oxygen from our atmosphere travels all the way to the moon, following something called magnetotail. That's a long extension of Earth's magnetic field, which can reach the near side of the moon. That's exactly where most of the hematite was found. And during a full moon, the magnetotail blocks 99% of the solar wind, which would normally influence the moon more. It's like there's a temporary curtain over its surface, which gives enough time for rust to form. But there's still one important thing necessary for the appearance of rust: water. It's not like you can find water that easily if you decide to take a walk across the moon. Most of it is frozen and hidden in areas that always remain in cold shadows. Those spots are far away from where most of the hematite was discovered, so it's hard to tell how the water got there. But for 3 sekpause. But there's an interesting idea. All those dust particles that hit the moon might be freeing free molecules of water that are locked in the surface layer of the satellite. This is how water ends up mixed with iron. We don't know exactly what these dust particles consist of. They might be carrying some water too. As they hit the lunar surface, this might create heat, which boosts the oxidation process, and more rust forms. So, our planet does certain things that change the moon, but humans do the same. A probe that landed on the lunar surface back in 1959 was the first human-made object that touched the moon. That's also when we started altering the moon in unpredictable ways. Scientists call this the lunar Anthropocene. Hyper 3 sekpause. It's like an analogy with Earth's Anthropocene, a period when human activity made a big impact on the planet. It's not like we can choose a certain starting point when such an activity began, but we now know that things we have done over the history of our existence have really changed the environment of our home planet. We don't have any people living on the moon yet, but we've already left some traces there. After humans first came to the moon, we've had many missions there. We left some landers and flags, moved lunar soil, brought golf balls, scientific equipment, and even some human waste. Plans for the future, send more missions up there, and even potentially create an infrastructure where some of us could live, study the moon's resources, and send them back to Earth. That's why it's important to talk about the lunar Anthropocene, to remind ourselves we have to be responsible and take care of our heritage. M6 3-sec pause. Many people are confused about why we sometimes see the moon during the day. Some even believe it's something new that didn't happen before, especially after they started sharing a low-res picture of what looks like a full moon in the middle of the day. Some have pretty unusual ideas that the sun isn't the same color as it was before, either. Allegedly, it used to be more yellow. The sun hasn't changed its color. It's still blue-green, but it's possible that we saw it as more yellow when we were younger because before, pollution wasn't as bad. And when it comes to the moon, we can see it both at night and during the day. It's brighter at night because there's no light coming from the sun. But it's not like it goes anywhere during the day. It's still there, but we just don't see it during the new moon phase. That lasts a couple of days, and during that period, the moon comes pretty close to the sun. The scattered light coming from the sun makes our satellite less visible to us. Pause. Speaking of the moon phases, they're easy to recognize when you know what to pay attention to. First, there's the black moon, which can mean a couple of things. One definition says that it occurs when we have 2 new moons in a month. Another one claims that the black moon happens when there's no new moon in a month, and that only happens in February. A blue moon is not called that because of the color. It's the 3rd full moon in a season that has 4 full moons. And a supermoon occurs when a full moon coincides with the moon's closest approach to Earth in its elliptical orbit. That's why it looks bigger than usual. 8-3-sec pause. Sometimes you can look up to the night sky and see an eerily red sphere up there. It's not about signs that tell us that the end of the world is coming or that werewolves are roaming around. But yup, blood moon is a good inspiration for stories like that. In reality, it's just an astronomical event when our planet casts a reddish shadow on the moon, and that happens when Earth comes between the moon and the sun, which is called a total lunar eclipse. Earth's little companion catches some red light coming from our atmosphere. That is why you see that specific color. A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called Quasi 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff like black holes and nebulas are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star, where the temperatures on the planet should be okay-ish, and water should stay liquid on its surface. It's not super precise, because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we'd get too many potentially habitable planets that are actually not habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between around 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, 2i715b is located there. This super-Earth orbits the M-type star, also called Red Dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, It's actually a better option for life. Red dwarfs live much longer than our sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. The sun is 4.6 billion years old, and this star is 6.6 billion years old. Give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more hyped, because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Another cool thing about TOI 715b is that it can not just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint that there might be liquid water below. And of course, we wonder if these planets can have life. Hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most exciting part about TOI 715b is that it's in the so-called Small Planet Radius Gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth, but there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range, they actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our sun does with gas from comets' tails. This gap holds a lot of mystery, and planets like our new super-Earth are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So, studying our discovered planet is even more interesting. It will help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we had already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-sized planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean that there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then, ground telescopes help determine their mass. With these three parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU Microscopii system. TESS detected a planet about 4 times the size of Earth, and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernovae, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come. As scientists continue to explore the vast expanse of the universe, they've made some incredible discoveries that have left them with more questions than answers. From a scorching super-Earth to a football-shaped world, the exoplanet discoveries of 2022 are truly out of this world. So hold on tight, the future of exoplanet discoveries is looking brighter than ever. Number 1, new type of exoplanets. Red dwarfs make up over 70% of all stars in space. So, in September of 2022, scientists decided to take a closer look at the small worlds orbiting them. What they found was amazing. New type of exoplanets that were made of half rock and half water, either in liquid or ice form. The researchers suggested that these planets likely arose from icy material and were born far away from their stars, past the ice line where surface temperatures are freezing. But they later migrated closer in to where the astronomers detected them. This discovery could have huge implications in the search for life in the cosmos. Though these planets are loaded with water, they might not be covered in oceans. Who knows? Maybe one of them will be the next Earth 2.0. Number 2, Jupiter-sized world. Imagine a planet so massive and mysterious. It's like a hidden Jupiter in our galaxy. Well, we just discovered one of those orbiting a star just 379 light-years away. Just haha. We've named it TOI 2182b, and it's got everyone talking. Why? Well, for starters, this planet takes a whopping 261 days to orbit its star, which is much longer than most distant gas giants we've come across so far. But that's not all. The temperature on this world is surprisingly mild, averaging at a balmy 170 degrees. For comparison, the temperature on Jupiter and Saturn is around 280 degrees. It's like a bridge between the giant exoplanets we found and our Jupiter. But the question remains, how did this planet get to be so different? Scientists are still trying to figure that out. Let's hope that we'll get some answers soon. Number 3. The Hulk planet. This world is a place where the surface is covered in molten magma, and the year lasts just half a day. Welcome to TOI 1075b, an exoplanet that's been dubbed the Planet Hulk by scientists. Located 200 light-years away, this super-Earth is one of the most massive ever discovered. Its proximity to its parent star causes its surface to reach scorching temperatures of 1,122 degrees. It's so hot that any form of water would evaporate instantly, and the air would be filled with vaporized rock. But it's not just the heat that's impressive, it's also its size. TOI 1075b is nearly 10 times the mass of Earth, making it one of the most massive super-Earths ever discovered. But the mystery doesn't stop there. The planet's orbit takes just 14.5 hours, making it one of the shortest orbital periods ever recorded for a planet of its size. What an exciting addition to our catalog. Number 4. 3 doomed planets. Astronomers made a shocking discovery of 3 planets that are circling in a dangerous dance next to the slowly fading stars. Just a decade ago, scientists never even imagined such planets could exist. These giant gas planets, similar in size to Jupiter, orbit way too close to their slowly fading stars. They're basically walking on the edge. Take one of them, for example, dubbed TOI 2337b. Its orbit will likely send it hurtling straight into the fiery arms of its host star in less than 1,000,000 years. Well, I won't be around then. As these stars enter their final days, they're pulling in nearby planets like a black hole, altering their orbits and potentially causing catastrophic collisions. And as these planets get closer to their stars, their atmospheres heat up and swell, leading to some mind-boggling differences in density. But despite the doom and gloom, studying these worlds could give us valuable insights into the evolution of our own solar system. Number 5. Planet with a barium's atmosphere. These are 2 hot, blazing planets, each with an atmosphere made of the heaviest element ever found in an exoplanet, barium. These planets, known as WASP-76b and WASP-121b, are ultra-hot gas giants called hot Jupiters that orbit incredibly close to their stars. These planets are basically like giant balls of fire, with one side facing the star, cooking at temperatures hot enough to vaporize iron and other metals. But as the hot iron vapor is blown to the planet's cooler night side, it turns into liquid and falls as iron rain. And these planets held a special surprise for us. Barium is a heavy metal, about 2.5 times as heavy as iron, and yet, scientists were able to detect it in the upper layers of these planets' atmospheres. This is truly a mystery and a puzzle that we're still trying to solve. Imagine landing on a planet like this and looking at this rain of iron and the heavy barium in its skies. That would be awesomely horrifying. Number 6, the football planet. Get ready to have your mind blown, space enthusiasts, because we've just discovered the ultimate football-shaped planet, and it's unlike anything we've ever seen before. Meet WASP-103b, the ultra-hot exoplanet that's more than 1,000 light-years away from Earth. This gas giant is so close to its parent star that its shape is being stretched by the intense gravitational forces. But this isn't just a fun shapeshifter. It's also a valuable scientific discovery. By studying the planet's passes across its star, we were able to measure its deformation for the first time ever. It's like taking a snapshot of a planet in motion, and it's giving us insights into the extreme conditions that these planets can endure. This is truly a great discovery. Number 7, a zodiacal light. Are you ready for a cosmic ghost story? Scientists and high school students in China have uncovered a spooky phenomenon on 3 distant exoplanets. It's called zodiacal light, a glow that's similar to the one seen here on Earth during sunset. But this isn't just some eerie light show. It could hold clues about the makeup of these potentially habitable worlds. Imagine watching the sunset from a dark spot on Earth, and instead of darkness, a triangle of light appears. That's zodiacal light. It's caused by sunlight reflecting off dust particles that fill the solar system, the remains of asteroids and comets. The team of researchers analyzed 47 potentially habitable exoplanets named Kepler-69c, Kepler-1229b, and Kepler-395c, all super-Earths, had signs of this light. This discovery is more than just a spooky phenomenon. It could reveal information about the presence of asteroids and comets in these exoplanet systems, which could be difficult to detect otherwise. So that's pretty neat. Number 8, a planet with silicate clouds. Introducing VHS 1256b, not a home video recording system, but a strange and exotic world, shrouded in mystery and wonder. A place where the clouds are made of sand and the sky is forever red. This isn't the stuff of science fiction, but a real-life discovery made by the brilliant minds at NASA. This is a brown dwarf exoplanet that's making waves in the astronomical community. It's way too massive for a planet, nearly 20 times the size of Jupiter. But it's not quite a star. It's something in between. A cosmic enigma that defies definition. But what's really crazy about VHS 1256b is its atmosphere. Scientists have discovered that this strange world is cloaked in thick clouds of silicate grains, similar to sand. It's the first time this kind of cloud has ever been detected on an exoplanet. And it's a discovery that's sure to change the way we think about the universe and the possibilities of life beyond our own world. And there you have it, folks. The year 2022 was filled with incredible discoveries and groundbreaking findings in the world of exoplanets, but this is just the beginning. As scientists and researchers continue to explore the vast expanse of space, we can only imagine what other wonders await us. So, let's keep looking up. Who knows what secrets the stars hold for us next? Imagine a black hole, a terrifyingly dense space object, pulling inside everything that comes too close. Nothing can escape its clutches, even a beam of light. And now, imagine two of these space monsters colliding. Scary? You bet! Astronomers have spotted two supermassive black holes feasting on the cosmic material of two merging galaxies in distant space. This phenomenon is the closest to colliding black holes we have ever seen. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times larger than of our suns. And two such giants have been recently spotted with the help of an array of telescopes in northern Chile's Atacama Desert. Astronomers originally used these telescopes to watch two merging galaxies located approximately 500 million light-years away from Earth. Thanks to being alert at all times, scientists have also noticed that two gigantic black holes were growing alongside each other. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, only 125 million times larger. We can't see black holes directly. If you were to travel to a black hole, you wouldn't notice it until it was too late. The only detail that would give away the approaching black hole would be a slight blurring of distant stars due to the hole's gravitational lensing effect. The two black holes we are talking about are no different. They aren't visible directly, but are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger, black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which, astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. The thing is, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around the black holes. Imagine how surprised astronomers were when, instead of one black hole, they discovered two of them, munching on the dust and gas stirred up by the massive space merger. Galaxy mergers are way more common in the distant universe than in our neighborhood, and this discovery may mean that such black hole binaries are likely to be much more common than we previously thought too. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes there are that are about to collide in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in around 4.5 billion years. By the way, the first photo of a black hole was taken in 2019. An international team of scientists consisting of more than 200 astronomers had been working for years to get this result, and their efforts finally paid off. The object in the photo is about 55 light-years away from Earth, at the center of the galaxy M87. You can now admire this amazing space phenomenon thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. The event horizon is a point of no return on the outskirts of a black hole. Once something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape. To capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order, with the help of precise atomic clocks set on each telescope. Plus, they were constantly monitoring the amount of moisture in the air, since too much humidity would ruin the images. To keep the chances of rain to a minimum, they even constructed the telescopes in super dry regions such as the Atacama Desert in Chile and the South Pole. All in all, the process resembled a carefully coordinated dance. But thanks to these preparations, in over 2 weeks, the telescopes collected 5,000 trillion bytes of data. It was then processed by several supercomputers, and scientists finally got the long-awaited images. And what they observed was a monster of a black hole, measuring about 25 billion miles across. Now how about we talk about the coolest black hole facts? There are baby black holes called primordial, and they are really tiny. They vary from the size of an atom to that of a mountain. There is a theory that galaxies get formed around black holes. This means that when a large star explodes, a black hole appears in its place, and then the rest of the galaxy just forms around it. There is a supermassive black hole right in the middle of the Milky Way galaxy. Its name is Sagittarius A star, and it's 4 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light-years away from Earth. That's too far for this monster to have any influence on our planet. Besides Sagittarius ASA, there are 100 million medium-sized black holes in our galaxy. And can you imagine how many black holes in total there are in all 100 billion galaxies that exist out there? You do the math. If you ever find yourself near a black hole, be ready that time will slow down significantly. It may work for you if you aren't so eager to grow older. Just don't let yourself be tugged into the event horizon. Whoops! Bye-bye! Black holes aren't some hungry predators that roam the universe preying on poor, unsuspecting planets. They just gulp down the stuff that ends up too close to them. On top of that, they sometimes fling out spitballs the size of a planet. How does this matter escape the pull of black holes? Typically, it manages to slip away before going past the point of no return. In fact, with Sagittarius A, we should be worried not about its gravitational pull, but about the very spitballs. After all, the monster black hole hurls them in the direction of Earth at a speed of 20 million miles per hour. What if one day one of them reaches our planet? If you manage to squeeze Earth to the size of a cherry tomato, it would turn into a black hole. In fact, you could also become one if you agreed to be scaled down to an atom. South African astronomers have recently come across another head-scratching black hole mystery. In a region of distant space, they noticed that several black holes located in different galaxies aligned in the same direction. It looks as if their gas emissions have been synchronized by design. Nowadays, scientists can't explain why and how black holes, which are about 300 million light-years away from one another, can be acting in unison. It's a puzzlement. Saturn's iconic rings will disappear in less than 2 years. Soon, we won't be able to see Jupiter's great red spot. Pluto's atmosphere might vanish any day now. Even the universe itself could be slowly evaporating right at this moment. But let me start from the very beginning. Saturn's rings won't vanish forever, at least in the nearest future, but they will seemingly disappear from view. This phenomenon is caused by the planet's tilt as it orbits the Sun. As a result, the eye-catching rings adorning the gas giant will get invisible to stargazers in 2025. This outrageous disappearance occurs because Saturn's thin rings turn edge-on. It's like holding a sheet of paper horizontally at eye level, parallel to the ground, so that only the edge of the paper can be seen. Something similar happens to the gas giant's rings. As the seasons on the planet progress, instead of the southern side of the rings tilted our way, we start seeing the northern side. But then the planet tilts again, revealing the southern side once again. Such a ring plane crossing happens every 15 years, when our planet passes through the gas giant's ring plane. The last time this phenomenon occurred was in 2009. Afterward, the rings gradually became visible again over the course of several months. This time, the rings will be edge-on in March 2025. Then they will slowly come back into view and disappear again in November of the same year. Soon after that, the rings will reappear, first becoming visible to the largest telescopes, later for everyone else to see. At the same time, further into the future, the rings might cease to exist for good. Astronomers have concluded that Saturn's rings, which mostly consist of ice and rocky dust from smashed asteroids, are younger than we thought. They're losing tons and tons of mass per second all the time, and it's likely to be a few 100 million years at most before they vanish completely. Let's move to the Great Red Spot on Jupiter. This immense raging storm might stop spinning in the next 20 years. The storm in question is larger than our planet. It was first spotted in 1830, but observations from the 1600s mention the presence of a giant spot on Jupiter too. If it was the same Great Red Spot, then we can say that the storm has been raging for centuries. The storm's vortex has remained so powerful thanks to Jupiter's 400 to 600 kilometers per hour jet streams. But like any other storm, the Great Red can't keep raging forever. It has been shrinking for a long time. In a decade or two, it's predicted to turn into the GRC, the Great Red Circle. And who knows, maybe it will later turn into the GRM, the Great Red Memory. In the late 1800s, the storm was more than 56,000 kilometers across, 4 times the diameter of Earth. But when Voyager 2 flew past Jupiter in 1979, the storm had already shrunk almost twice its original size. And this shrinking is still happening. In 2017, the GRS spanned the width of a bit more than 1,635 kilometers, less than 1.3 times the diameter of Earth. Moving on, Pluto's atmosphere is going through a weird transformation. This icy dwarf planet, sitting over 4 billion kilometers away from Earth in the region of the Kuiper Belt, drew astronomers' attention in 2018 when it passed in front of a star. With such a powerful source of light illuminating Pluto, researchers managed to examine the dwarf planet and its atmosphere. They came to a shocking conclusion that Pluto's atmosphere is refreezing back onto its surface as the dwarf planet gets colder and colder. Astronomers used several telescopes in different spots in the USA and Mexico to observe Pluto and its thin atmosphere, which is mainly made of nitrogen. This atmosphere is supported by the vapor pressure of ice on the surface of the dwarf planet. For around 25 years, Pluto has been moving farther away from the Sun, and its surface temperature has been gradually going down. Pluto is really far from our star at the moment, but at one point, it will start getting closer in other regions of its incredibly huge orbit. Besides Jupiter's Great Red Spot, Saturn's rings, and Pluto's atmosphere, we're also losing stars. But stars don't vanish, right? For thousands of years, scientists believed that lights in the sky were fixed and unchanging. Even after they realized those lights were physical objects just like the sun, they were still sure that stars went through major changes extremely slowly on timescales of millions and billions of years. In reality, though, the most massive stars, which can be hundreds of times heavier than the sun, can go through sudden catastrophic events. For example, once they reach the ends of their lives, they pass away in blinding explosions of supernovae, shining for months on end and visible across hundreds of millions of light years. But there are stars that seem to just wink out of visibility. It should be impossible. And over the past years, a group of researchers tried to figure out whether there's actually a chance of such a phenomenon happening. They started to compare data collected over decades of observations. The project is called VASCO, the Vanishing and Appearing Sources During a Century of Observations. The scientists are interested in all kinds of disappearing objects, but they are hoping to find a star that was steady and present for a long time and then just vanished without a trace. Even if you point a super powerful telescope there, you'll still see nothing. Our current understanding of space and its laws suggests that stars change very slowly over long periods of time. Dramatic disappearances are supposed to leave noticeable traces behind. Of course, it doesn't mean that all stars should shine steadily. The sky is filled with stars that change in brightness and pulsate, but VASCO is about something very different. They want to find something that goes from a completely steady star to vanishing entirely. Such a phenomenon hasn't been documented yet, and such a discovery might lead to new physics. And now, let's move on to the most disturbing part, the one about the evaporating universe. According to a famous theory proposed by Stephen Hawking, black holes, the densest objects in the universe, evaporate over time. They lose mass in the form of bizarre radiation. But a new study claims that Hawking radiation, or something very similar to it, might not be limited to black holes. It's likely to be everywhere, and it could mean that the universe is slowly but surely evaporating right in front of our eyes. Now, Hawking radiation is something no one has ever observed, but theories and experiments suggest that it can actually exist. Let's see how it works. There's a misconception that black holes are cosmic hoovers, slurping up everything that comes too close with the help of their immense gravitational pull. In reality, though, black holes don't have more gravity than any other body of a similar mass. What they're famous for is their density, incredible amounts of mass packed into a tiny, tiny space. Within a certain proximity to such a dense object, gravitational pull becomes so powerful that it becomes impossible to escape. Not even the speed of light in a vacuum is enough, and that's the fastest known thing in the universe. At the same time, anything massive or dense enough can produce a serious curvature of space-time. In simple words, the immense gravitational field of these objects makes space-time wrap around them. Even though black holes are the most extreme example, space-time also curves around other super-dense objects, like white dwarfs and neutron stars, or galaxy clusters. It means that any super-dense and supermassive object can have some sort of radiation similar to Hawking radiation. And after a very, very long period of time, it could lead to everything in the universe evaporating, following the fate of old supermassive black holes. If it turns out to be true, it will change our understanding not only of Hawking radiation, but also our view of the universe